In today's business world, we are defined by our connections. DataChemist helps bring those connections and relationships to light. Let me show you how. This dataset includes 2.5 million named entities, companies and people, and 2 billion relationships between them, covering the last 20 years of the Polish economy. It's a huge dataset, and whilst all this data is publicly available, until now, gleaning meaningful insight from this data was either slow and painstaking, or when it comes to relationships and deep relationships, simply impossible. Just to talk you through this, the blue nodes are companies, the green nodes are people, and the red nodes are management boards. The graph shows the network of power, those who own and control the companies. And this application allows us to explore the network of business connections across the entire Polish economy over the last 20 years. And we can see how these networks and relationships formed and changed over time, just this easily. The idea is that we can instantly call up any company or person like this and see their business interests and connections. And in this case, I've selected a super connected node. As you can see, this individual sits on 204 management boards and holds shares in 119 companies. I don't know how he gets the time, but we can also instantly see where his business interests are located on the map here. And we can do this even though we've scrubbed the database of actual personal individual information. We also use a unique gravitational model whereby the nodes that are most densely interconnected stick close together, and this allows us to see interesting patterns in the data. These red dots here are management boards. They've been pulled away from their companies by the gravity of our hyperconnected individual, and it's a great visual indicator of where power actually lies. If you're doing business with any of these companies, maybe you should just talk to this guy. We can find other interesting things in the data. This shows a complex shareholding pattern between companies involving multiple shareholding cycles, which is known by accountants as a washing machine structure. In other words, company A owns or part owns company B, owns or part owns company C, owns or part owns company A. And again, we can see how these relationships evolved over time and where everything is physically located. The interface is generated from our semantic model, and it allows us to select whatever relationship types and parameters we have defined in the model. For example, we can include company trustees like this in our analysis, and we can see an interesting situation here where the same individual is both a trustee and a member of the management board at the same time. And better yet, we can establish, just like this, that this trustee appointment happened in 2016-17. We see an interesting pattern we can investigate further. Of course, if you wanted to find this type of information manually, it would take a while. But under the hood, we have a query API which allows us to find very complex relationship patterns in the data very quickly and very easily. For example, we can find the shortest path between any two people or companies over whatever combination of relationship patterns we want. So in this case, these two sample individuals I'm using are connected through shared shareholdings in 3 companies, connections that involve 2 other people. And now one final query in terms of the fastest route between 2 individuals. One of these particular people is a super connected node. It would require more than 1 million joins of SQL tables. However, we achieve this rapid performance that happens almost immediately using a compressed, highly parallelized, in-memory graph storage engine. In this case, we find a complex connection between the 2 individuals involving a company bankruptcy and 2 management boards, and again we can explore further. The last few years have seen a new revolution in computer architectures towards machines with very large numbers of CPUs. Google offer a standard VM with 1,024 cores and terabytes of main memory. That means that although 2 billion relationships, as in this example, sounds large, it's only scratching the surface in terms of the size of datasets that we can query without degradation in performance. We estimate that we could scale comfortably to cover every company and connected individual in the world since 1900, simply by using the biggest commodity cloud VMs available today. Data is the new oil. DataChemist is the oil refinery that turns these vast datasets into real insight and real knowledge.